Hey everyone, I hope you're having a great day. I wanted to discuss everything you need to know about mechanical engineering and what you should expect from the field of study and the profession. I'm going to go over one, the concepts and skills you need to learn while you study it in college, two, the types of jobs you can get, and three, what you can expect in terms of compensation and work-life balance in those jobs. So you'll be able to identify how well mechanical engineering aligns with your personal goals. Be sure to stick around to the end of the video, as this information can help you a lot in deciding whether or not to pursue the field of mechanical engineering and what you can expect from it. So let's talk about the very beginning. So what's learned in mechanical engineering programs? So I'm just going to go a kind of brief overview of this, but think about going much deeper into physics or specifically the mechanics class that you may have taken in high school or in college. So talking about motion, gravity, forces, energy, stuff like that. And so you're going to deal with a lot of equilibrium, balancing forces, and seeing if this turns out to be a statics problem or a dynamics problem, dealing with structural stresses in parts and materials to make sure they're not going to fail, and then learning about thermodynamics and heat transfer and power cycles, thermal systems, and then some basic modeling in SolidWorks for 3D parts, in ANSYS for models for structural analysis, MATLAB and others. MATLAB where you do a lot of sort of coding math and matrices type of stuff. And then you do dabble a little bit in some miscellaneous stuff like circuits, statistics, design of experiments, and just miscellaneous topics in general that could be relevant or could be kind of in your field that would be relevant to mechanical engineering. So then, how does this translate into what types of jobs mechanical engineers get? So I'm gonna, for the sake of this video, break this up into three categories, focusing mostly on the first two. So positions that are either titled mechanical engineer or something that's like a subset of mechanical engineering. So like structural engineering, where you're doing failure analysis on structures, or tooling engineering, where you're developing basically tools or machinery for manufacturing. So these will tend to be at least loosely related to what you studied in school. You're probably not going to use the vast majority or the majority of what you learned in school, but you're probably going to, in structural engineering, heavily emphasize stress analysis and structural analysis and failure modes. Tooling engineer, you're going to focus a lot more on SolidWorks or other CAD design. So that's the first category, is stuff that's more directly mechanical engineer related. The second one is other engineering positions that aren't mechanical specific, such as project management or testing of certain machinery or electronic components or interfacing with customers. And we'll get into that later. And in some cases, you may do well with non-engineering positions, maybe in manufacturing plants or in technical settings, but or just completely unrelated. Employers see you, oh, this person got a mechanical engineering degree and they're smart, let's hire them. And I don't intend to talk about this really in this video, although that's definitely a possible outcome. So let's focus on the first two of these. So talking about more directly mechanical related positions, so you got mechanical design where you're doing CAD and GD&T, so you're doing 3D models of parts in SolidWorks or other CAD software. Then geometric dimensioning and tolerancing, aka GD&T, is where you assign ranges that each dimension can basically be manufactured to in order to pass inspection and be accepted for release. Because if they're outside of those dimensions, then they're not actually going to be acceptable for selling to the customer. And then the second position type is structural analysis. So finite element analysis, assessing what the high stresses are in parts or joints, failure modes of the part or assembly using statics, dynamics, testing. Then you might do stuff like fluid systems, like propulsion systems or power cycles, and just assessing what certain forces are and certain phenomena for fluid systems are to make sure they're acceptable in the design. Thermal analysis to make sure balancing temperatures across a system works properly and can be acceptable. So yeah, that's kind of a brief overview of what kinds of mechanical engineering positions you could possibly get. And then other types of mechanical engineering jobs or just engineering jobs that aren't directly mechanical. You might be doing project management type of stuff where you're dealing with schedules and budgets of a project, and it's going to help that you know how to sort of speak technical languages, even though you're not going to be directly doing technical work. And then field or application engineering, where you're at the customer site helping them to implement your company's product or solution in their processes, or kind of similar sales engineering, which in some cases is not going to be super technical, or in some cases it'll be you're going to be doing simulations of the customer's specific scenario or interacting with the customer, speaking the technical language to help them to understand the fit of your company's product into the customer's processes. So yeah, this is all stuff where the technical knowledge is going to be useful, but you're going to learn the company specific stuff on the job, and it's not going to necessarily directly use super specifically mechanical engineering stuff. Let's talk about compensation and work-life balance, which are certainly quite relevant to the decision of whether to study mechanical engineering or not. So, starting salary, the average for mechanical engineers is somewhere between 60 and 70K. And then BLS shows the average for all engineers is around $102,320. So this is certainly higher than the average household income. And that's actually pretty good because the average household income, that number is probably skewed by the fact that it might be two people working. And so this is just one person working. So for the most part, pretty solid. You're getting paid more than a lot of people, and you might be paid more in certain disciplines and or more expensive geographical areas. So that depends a lot on the situation and the position. So for the most part, solid middle class life. Nowadays, I mean, with the cost of living having gone up, unfortunately, it's not like you're going to be super rich. You're not going to be able to afford three houses and go on a ton of vacations or tons of luxuries in general. But I mean, you could comfortably support a family and middle class lifestyle in the average geographical area. So in a lot of different parts of the country where the cost of living is not super high, this should be pretty comfortable. In more expensive areas, it is true that you'll likely make more than the average, but from what I've seen, it's usually not proportional. Like if you work at a plant in the Bay Area versus at a plant in Chicago, for instance, they're not going to adjust your salary perfectly proportional to the cost of living in the Bay Area. It might be like 10 or 20% more, but not the salary might be like 10 or 20% more, but from what I've seen, unfortunately, it's not proportional usually, so it is a net negative in terms of cost per salary. But also in highly specialized fields or higher up the corporate ladder, you'll likely make more. Some highly specialized fields in aerospace or in oil and gas and such might make quite a bit more than the average person. Or if you climb the corporate ladder or go into management, into leadership, then that'll probably affect that as well. So for the most part, design analysis type of positions will have pretty standard working hours, and positions that support operations may have longer and or non-standard hours. that's kind of a general trend. There are certainly exceptions to this. Well, for one thing, even work that's in a manufacturing plant, some companies still tend to have a pretty strict work schedule where everyone kind of works during like 7 a.m. to 5 p.m. or 8 a.m. to 5 p.m. or something. So in some companies, it's not necessarily going to be 24/7 or like random evening shifts or weekend shifts or anything like that. But, and also on the flip side, some companies that are more strict, like SpaceX, for instance, or or semiconductor companies like Intel, they might be more strict about working longer hours and working on the weekends and such if stuff needs to get done. So it's not a perfect correlation, just a general trend. And so that is where it could be important to study up on the company to see what kind of work-life balance they have and whether or not you'll be comfortable supporting it, or if you need to take the position for now to get experience, but have a plan to go to a company with better work-life balance. So a lot of variables here, but these are the general trends that I'm attempting to give you. Yes, I think that's the overview of mechanical engineering and what the jobs are like and the compensation is like and such. And I hope you found this helpful. If you did, be sure to give this video a like and subscribe to this channel to stay in the loop for advice about engineering careers, how to be successful. And thanks for tuning in. Be sure to talk soon and see you in the future videos. Bye.